Good afternoon, ladies and gentlemen. I know the post-lunch session in any seminar is the most difficult session. And to actually keep you energized, we have two very young and dynamic air warriors with rich experience and recent experience in the fighter squadrons. And who else are the better people to talk about air defense and talk about the lessons one would learn in any conflict? Because all the time we are in the business of preparing to tackle such conflicts wherever and whenever called for to do so. So without much ado, I would request Group Captain Nandagopan, who is from OPAG, it's a very, very important directorate in the air headquarters, to give his analysis of the lessons learned from the Russian-Ukraine war. Over to him.
Thank you, sir. Good afternoon, ladies and gentlemen. Thanks for giving me this opportunity. The Russia-Ukraine conflict, as we know, is into its 515th day today. The conflict has pitched a formidable Russian power against an adversary whose comparative military power is but a fraction. The ongoing special military operations, as has been named by Russia, have provided invaluable strategic, operational, and tactical lessons for defense analysts, academia, and military professionals alike. The presentation today shall, however, be confined to an air power practitioner's perspective on the air operation and specifically air defense operations in the Ukraine conflict and the lessons that can be gleaned from them. The research behind these arguments is based on open source data, and my argument is purely academic. The presentation shall be covered under the following heads. Before we step threadbare into the Ukraine conflict and air defense operations undertaken, it would be prudent to study air defense philosophies and architecture of both the forces. Post-World War II, up to the late 1980s, Soviet military doctrine advocated a strategic defensive posture with the primacy of air defense. The end of the 80s saw a shift of the Soviet concept of strategic defense to strategic active defense. The concept separated conflict into two periods, that is crisis and war. In period of political crisis, the concept alluded to preventing war through either passive deterrence or, if I may say, coercion. In a period of war, the concept advocated the adoption of maneuver defense and counter-offensives to roll back gains, if any. Post-1991, active defense has continued to shape Russian military and air strategy, and to some extent, Ukrainian military and air strategies as well. Ukrainian military strategy is a legacy of Soviet way of war with heavy influences of NATO in the recent times. It is the predominance of a strategic defense with a mix of defensive and offensive actions at the operational level. Air strategy mirrors the military strategy of degrading enemy air power through defensive and reactive philosophy based on defending, absorbing, and regaining. Defense is undertaken majorly by units of surface-to-air missiles, that is SAMs, and man-pads and counter-offensives are executed through airstrikes using UCAVs and manned aircraft. It is a classical strategy that aims at maximizing asset application and raising the level of risk to Russian air power. Now, when we connect these two philosophies that were known prior to 24th Feb 2022, when the special military operations began, it is probable that some linkages between theory, history, and practice may emerge. A small brief on the AD architecture of both forces is important at this juncture. AD role of Russian forces is shared between the Russian Air Force, or called the VKS, and the Russian Army. The role of VKS is access denial into Russian airspace through control of high altitude and long distance AD systems such as S-400. The Russian Army controls the battlefield AD systems, short-range air defense missile systems, and S-300 area denial systems. There is thus an overlap of command and control of AD functions between the two services in the long-range high-altitude AD zone. And ladies and gentlemen, this is a very important aspect which I'll come to subsequently. Hence, this would require a high level of inter-service coordination. Ukraine's AD structure reveals a possible centralized command control structure where air defense of airspace is the sole responsibility of a single service, that is the Ukrainian Air Force, or also known as PSU. Within the PSU, it is the responsibility of anti-aircraft defense rocket forces that were previously merged with PSU in 2004. Now a brief rundown of air operations and specifically AD operations conducted so far. From 24th Feb 2022 onwards, for a close to a week, the VKS undertook a seemingly effective air op campaign where it conducted parallel air operations for achieving control of air, degrading the war-waging and war-making potential of Ukraine while defending Russian assets from air attacks. Russia extensively employed surface-to-surface missiles as well as fighters and helicopters against major military targets. Initial air superiority was most likely achieved, but after initial gains, somehow offensive counter-air operations appeared to have been toned down. For air defense, VKS adopted a concept of offensive air defense where the AD umbrella was extended into the Ukrainian territory with the placement of long-range SAMs, close to the western border. It is assessed that the expanded coverage of Russian long-range SAMs, specifically the S-400, into Ukrainian airspace might have dissuaded the balance of Ukrainian air power from operating freely over the eastern and central Ukraine. However, VKS AD operations were not completely flawless. It is reported that VKS forces, despite having a network AD setup, appeared slightly lacking in capability for simultaneous application of surface-to-air guided weapons as well as combat aircraft in the same theater and common battle space. This was probably due to inadequate training and lack of complete automation and deconfliction. PSU, on the other hand, adopted a strategic defense posture, as is expected out of a weaker state, and was able to deny control of air to a much stronger adversary through a combination of mobile, agile, and innovative air defense operations. Its command and control architecture also probably served it well, where despite significant losses to its capabilities and capacities, as well as loss of rudimentary AD network, which was known as the IADS, PSU AD systems continued to function relatively, albeit with degraded functionality. PSU air defense prevented VKS from sustaining the air superiority that had been gained over a week. As a result, majority of VKS aircraft were either avoiding overflying Ukrainian airspace after the initial phase of the campaign. PSU surface-to-air missiles caused attrition at low levels and medium levels in the initial day of campaign and restricted VKS to undertake standoff, high-level bombing with probable degradation of accuracy. Perseverance and effectiveness of PSU AD continued to increase as the Western aid started to flow in. Air defense operations over Ukraine thus provide valuable lessons at the operational and tactical level of warfare and are elaborated further. Providing gap-free air defense in a voluminous airspace is a challenging task. Therefore, offensive air operations must complement air defense operations by degrading the offensive air capability of the adversary at the source. The VKS counteroffensive in the first week of the air campaign was well executed and resulted in a high degree of control of air. It degraded PSU offensive capability and thus complemented VKS AD operations that consequently reduced to bare minimum. This enabled preservation of VKS AD assets and opened up options for diversion elsewhere. A high degree of control of air is not only blunts an adversary offensive capabilities, but also provides and if sustained and maintained, will ensure that the offensive AD and area denial weapons are used. Extensive use of S-400 deployments by VKS was indicated of the concept of using long-range SAMs to have control of air. That means ground-based AD systems for control of air. Pardon me, I'll just reserve. Coordination in employment of air defense systems is another important aspect. As we know, as I covered earlier, there is an overlap of control and AD functions between the Russian army and the Russian Air Force, that is VKS. Hence, the AD systems were operated by different services, primarily S-400 being operated by VKS, while S-300 was being operated by the Russian army. Hence, there was possible zones of overlap of command and control functions. Such overlap is efficient in case the coordination is available and the AD systems are networked. However, as was evident in the subsequent part of the air campaign, this coordination was lacking. The coordination when lacked, when employing critical area denial weapons, further ensured that there were tactical pauses in the application of air power, and the air campaign in itself slowed down and moved towards supporting the ground campaign. Therefore, common AD communication networks is an absolutely essential when we come to air defense operations. Active and passive AD against long-range vectors. The highlight of this campaign has been the extensive use of long-range vectors by Russia against Ukraine. An estimate is that in the initial salvo itself, Russia fired about 200 precision-guided weapons in the first week of the war. Till today, Russia has fired about 7,000 long-range vectors and includes 3,000 Shahed 136 drones. Although PSU in the initial, as guided by the NATO observers, was seen to be dispersing its asset to mitigate the effects of Russian long-range vectors. However, the question is the losses of Ukraine to immovable standing assets which cannot be moved, which includes military and civilian infrastructure and shelters which were above the ground, was not successful. There are contrary reports, I may admit, that significant missile interceptions by PSU were undertaken throughout the war, which includes up to 80 to 90% of Shahed drones being intercepted by PSU. However, the question is, even if 10% of drones have escaped the interception, what kind of damage they have done? In addition to not only use of long-range vectors, not only to the AD system, also creates a high psychological impact on the civilian population as well as military personnel. Active and passive AD measures, therefore, are very important in modern conflicts against long-range vectors. Missile defense systems, terminal weapon system, close-in weapon systems, non-kinetic options, hardened air shelters, underground complexes, dispersion of assets, and agility solutions were some of the solutions which were identified during the conflict against such vectors. Lethality of manpads has been debated in the initial part. However, with the disintegration of PSU, integrated air defense system, the shoot and scoot philosophy employed by Ukraine was found to be highly effective. Hence, manpad is an effective weapon system throughout the conflict. Mitigation of manpad threat, therefore, is an essential aspect, and it involves not only countermeasures, but also sound TTPs. These manpads, these effects are cost-effective and a viable AD system with relevance in modern conflict. Procurement and employment, thus, of manpads must continue. We have seen in the initial part of the war that Hepters and transport aircraft were observed to be vulnerable to the AD in conflict. Threat to AD a reality, but I would still admit that these can be mitigated by correct tactics, training procedures, and tech. The tech involves for protecting these slow movers, that is helicopters and transport, is EW, self-protection suites, and low observable technology. Low RCS threat is a reality. We have all seen how effectively Ukraine employed the Bayraktar TB2 drones, and subsequently Shahed were employed by Russia. However, these drones, that is both Bayraktar and Shahed, lost effectiveness because of evolving AD's infrastructure of VKS and PSU. AD capabilities and peacetime and wartime AD plans thus must cater for this specific threat. Non-kinetic AD measures, we have already seen being discussed in the initial part of the seminar. We need to have capability to research and adapt to GNSS jammers, RF link jammers. Extensive use of hypersonic AD systems by Russia was once again a a key highlight of the conflict. These were used to target military and civilian infrastructure deep inside Ukraine, and at the same time, the conflict has also shown that the anti-missile AD systems are capable of intercepting some of these hypersonic weapons. A case in point is the oft-repeated claims by Ukraine of shooting down multiple Kinzhal missiles. While some of these claims may be true, it is important to understand that Kinzhal is not a pure hypersonic weapon. It is an air-launched version of Iskander ballistic missiles. However, modern hypersonic systems like Zircon, Avangard, and DFZF by the Chinese that employ scramjet and hypersonic glide vehicle technology would be far more challenging to intercept. Ladies and gentlemen, as the conflict has progressed, I would like to highlight an important change in AD calculus. The proliferation of small, cheap, and long-distance methods to attract infrastructure is causing pain across Russia and Ukraine. Although each side claims 80 to 90% interception rates of these cheap vectors, the real question is if the interception of even 100% of these vectors with missiles, with expensive missile, is really a win in AD parlance. There are too many locations to defend, too many incoming vectors that are a mix of both high cost and low cost to interdict, and too few capable and cheap AD systems are available to do it. Therefore, until air defense becomes as numerous, inexpensive, and capable as the threats it must protect, air defense, purely depending on air defense, will continue to remain an expensive affair, and relying solely on an effective AD umbrella against an adversary will be a purveyor of false hopes. Network operations is one of the important aspects of today's modern conflict. Networking is essential for cooperative target engagements and also to ensure that there is no fratricide. This must be complemented by training and interoperability. The VKS was found to be suboptimal initially in these aspects. However, as the conflict progressed and the need for a network system was envisaged, they introduced integrated communication and command systems such as Strelets-M and battlefield management system like Andromeda. The question is if it was too late. On the other hand, what PSU did was to operate on a completely non-network environment. Hence, we must remember, striving for a network environment is one aspect of a war. However, training for an eventuality of operating in a non-network environment is also essential. Geography and AD have a symbiotic relationship. Most ground-based AD sensors are susceptible to line-of-sight restrictions. The terrain in Ukraine was ideal for AD operations because it provides the line of sight, it's free from the line of sight restrictions. Undulating mountain terrains, in our case, poses its own challenges. Therefore, the lessons that we draw from the Russia-Ukraine war in terms of AD cannot be copy-pasted into our scenario. We must look at our strengths and our weaknesses when it comes to the terrain in which our AD is going to function. To conclude, Russia-Ukraine war has given us important lessons in air defense. One of the most important lessons that the conflict has shown us that relying on air defense as a singleton operation is not the future. Air defense is part of a whole gambit of enmeshed air operations which needs to be sustained and which need to be continued to ensure that you continue to gain against the adversary. Two important aspects that this conflict has shown us is the importance of hypersonic weapons and as well as unmanned air systems. While on the one hand, the hypersonic weapon systems are difficult to detect, identify, and intercept with the modern day technology, unmanned air systems, especially cheap, are likely to overwhelm our AD infrastructure. Finally, I would like to say that the argument of air defense solely depend on surface-to-air missile systems is based on strong foundation, as the conflict has shown that in a contested airspace, the combat aircraft still has its relevance. Thank you.
Good afternoon, ladies and gentlemen. The landscape of modern warfare is constantly evolving with advancements in technology. The evolution of next-generation air-to-air and air-to-ground weapons represents a significant leap in military technology, bringing about unprecedented challenges for global defense systems. These advanced weapons leverage state-of-the-art technologies, enhancing their lethality, precision, and survivability and pose considerable threats to contemporary and future military operations. I will be restricting today's talk to the operational domain of air warfare. The operational perspective on new generation air-to-air and air-to-ground weapons focuses on enhancing legacy capabilities and enabling multi-domain operations. New weapons are designed to improve ranges, all-weather capability, and precision attack as compared to the legacy systems. This includes developing technologies that enable all-weather endurance and neutralization of time-critical targets over multiple locations with simultaneity. Weapons are being designed across for various air platforms, allowing for greater flexibility and adaptability. The fifth generation air warfare concept emphasizes on a network-centric approach, integrating advanced digital networks to support fast-paced multi-domain operations. This involves leveraging assets from partnerships to achieve greater situational awareness and share a common operational picture. The development of new weapons prioritizes adaptability and resilience, enabling rapid mission planning and execution, and reducing operational pauses to sustain combat operations. This involves the concurrent adoption of tactics, techniques, and procedures with regular updates based on exercises and wargaming. These operational perspectives highlight the focus on enhancing legacy capabilities, enabling multi-domain operations, and developing adaptable and resilient systems to maintain a decisive edge in future conflicts. Classification of air-to-air missile can be carried out in many ways. Traditionally, the A4Ms have been classified into generations. For example, AIM-9X, ASRAM, Python 5 are the examples of the latest generation short-range A4Ms. However, BVR were earlier classified based on their guidance capabilities, and now they are classified in terms of ranges. Earlier, the BVRs were classified as active, passive, or semi-active. However, with tech advancement, it is generally classified as long-range or very long-range air-to-air missiles. The long-range missiles in today's scenario are the Meteors, AIM-120D, Astra Mark II, which is under development, Mika, R-77 Alpha. The very long-range ones are the Russian origin R-37, R-33, Chinese origin PL-15 and 17, and in development phase, the Joint Advanced Tactical Missile AIM-260 and Astra Mark III. So finally, what has changed that has made these new generation weapons as potent that they pose significant challenges in air combat? Tech advancements has resulted in improved propulsion and sensor performance, resulting in adoption of various trajectories, which has resulted in achievement of longer ranges, agility and form factor to meet the requirements of fast-paced air combat, and carriage capabilities of modern stealthy platforms. This has also resulted in sensor fusion to maximize effectiveness of the weapon, like high off-boresight capability and launch on afterlock. These weapons are more resistant to countermeasures, thus making them more lethal. It has also resulted in the expansion of no escape zone, thereby increasing the lethality and probability of kill. The implications of these advancements in an op environment translates to target's ability to detect and evade, wherein the target aircraft may not get sufficient early warning. This highlights the importance and need for a credible and potent automatic self-protection suite. It renders an advantage to the site that can generate and sustain conditions for weapon employment. Even if the perception is equivalent, the site with better range and effective missiles will have an inherent advantage. Since first shot capability forces the adversary into evasive action, it compounds to the advantage to the shooter. With very long-range air-to-air missile capability exists to target the enablers operating in deep territory, thus causing severe degradation of adversaries' essay and freedom of operation. New generation aircraft will continue to become a costlier proposition. In future air warfare, fourth generation aircraft are unlikely to be able to push into high threat zones. However, they will be able to employ long-range weapons by capitalizing on the information received from few advanced survival platforms, thereby offsetting the munitions deficit of very low observable designs. Notwithstanding, along with the advantages, there are certain caveats and limitations. During operations, information is shrouded in uncertainty. Lack of transparency may limit employment opportunities. The requirement of advanced sensors and equipment to identify high confidence targets from radar blips and resilient networks to transmit the targeting information will be a key to employ these weapons. There will always be dependence on performance factors like the sensors and system of system for leveraging the true capabilities of the weapon. Rules of engagement needs to be dynamic in such scenario. Efficacy and challenges of weapon employment in high combat density environment needs due consideration. On similar lines, tech advancements in precision, range, modularity, size, weight reflect the drive to develop air-to-ground weapons that can effectively engage targets while mitigating the risks to the aircraft and aircrew in the face of increasingly capable and potent air defense systems. The challenges posed by these weapons are the hypersonic weapons, which is a weapon with high accuracy with speeds more than 5 Mach. Detection, tracking, and interception are going to be major challenges. These weapons need not fly evasive profiles to avoid detection. Its speed itself gives it a significant advantage, enabling it to penetrate adversary defenses and reach the target. Therefore, advanced radar systems or a combination of radars with high-speed processing power are required to track and process the information in limited time available. Space-based detection and collaborative tracking are also being looked into as optimal solutions. Precision-guided munitions and air-launched cruise missiles are long-range weapons which have advanced guidance systems for navigation and multi-sensor terminal guidance for accuracy. Various trajectories and profiles can be planned to avoid detection and interception. The weapon ranges allows the platform to remain outside the effective engagement envelope of modern AD systems, thus enhancing its survivability. However, it has its challenges in terms of likely degraded performance in the event of jamming and misguidance due to GPS denial and spoofing, disruption and hardened electronics owing to electronic countermeasures. With evolving development of artificial intelligence, autonomous targeting is going to be a reality soon. However, it will have its inherent ethical concerns. For effective employment of these weapons, there are certain caveats. Based on the characteristics of terminal guidance, there will be data dependency for planning, which highlights the need for dynamic, accurate intelligence. These kind of weapons are mostly suited for engaging planned targets. Lack of target information may result in degradation of weapon performance in terms of accuracy while undertaking opportunity targeting. It is also imperative to develop the capability of battle damage assessment to substantiate own claims, carry out follow-on planning, and eventually control the narrative, more so in case of no war, no peace scenario. The precision paradox in new generation air-to-ground weapon refers to increasing accuracy and precision that can result in increasing feasibility of application of military force. Pinpoint accuracy and lethality espouses a thought that fewer numbers would be able to achieve the operational objectives. But due to the reach and lethality, it makes the use of military force more feasible in the situations where it may not have been previously possible and opens up more options for targeting, thus the need for more weapons. Owing to long ranges, there are limitations on the weight of the warhead which may not achieve the desired degree of destruction, thus necessitating employment of multiple weapons. Precision-guided munitions and standoff capabilities are becoming more abundant and richer, cheaper, increasing the chances of their proliferation to non-state actors like the terrorist groups and criminal organizations. This allows them to cause more damage than in the past. The standoff capabilities of precision weapons challenge the ability to retaliate and eliminate threats in real time since the actors can attack from larger ranges. As precision weapon technology advances, the ability to deploy these systems remotely and with greater autonomy is likely to increase while reducing human involvement in the targeting process and thus raising legal and ethical concerns. To summarize, the precision paradox highlights how the increasing accuracy and proliferation of precision-guided aerial weapons can paradoxically increase the requirement, cause more harm to civilians, empower non-state actors, and expose limitations in the existing legal and regulatory frameworks governing these technologies. The next category of weapons are the drones and the loitering munitions. They are presently available with extended range. Owing to their size and speeds, they pose a significant challenge of detection. They are low cost, but have the capability to consume high-tech AD resources of the adversary. In swarms, they can overwhelm any modern AD systems. Though the carriage is limited, they have the capability of inflicting damages which has potential to generate larger effects, like targeting high-value targets on ground. Even bunkers, hardened structures, vehicles, and foot soldiers are no longer safe, as seen from the effects of front pilot view in the Russia-Ukraine conflict. It can also be used for jamming and EW functions while acting as decoys to saturate the adversary AD systems with hard and soft kill options while complementing own offensive. Though both classes of new generation weapons have significant advantages, cost and availability will always be a major concern. Lessons from recent conflict highlight the need to acquire a resilient capability of production and sustenance to support protracted operations. Developing a single integrated system to handle these threats may not be feasible for defense against these new generation weapons with such a large variation in characteristics and speed. Therefore, there is a need to integrate multiple systems with multiple sensors in a network environment to detect, track, and intercept both actively as well as passively, including low-cost solutions, that too in multiple tiers. The need for cutting-edge capabilities, enhanced lethality, and improved defense mechanisms fuels the procurement of next-gen weaponry. Breakthroughs in artificial intelligence, material science, and precision engineering enables the development of cutting-edge weapon systems. The allure of these highly advanced and efficient weapons drive military modernization efforts worldwide. As nations prioritize staying ahead in an increasingly complex security environment, the demand for technologically advanced weaponry continues to surge, shaping the landscape of defense capabilities for the future. In an era defined by rapid technological progress, the landscape of aerial warfare has undergone profound transformations. The deployment of cutting-edge aerial systems marks a pivotal shift in how nations perceive and engage in warfare. Comprehensive knowledge of these weapons enables military planners to develop effective strategies. Understanding their range, speed, stealth capabilities, and target precision allows for better preparedness in countering potential threats. A thorough understanding helps nations protect their airspace and territories against potential adversaries equipped with advanced aerial weapons. It allows for the development of robust and cost-effective defense systems and countermeasures to counter a wide array of threats. Awareness of new generation aerial weapons drives technological innovation. It encourages nations to invest in research and development to maintain technological parity or superiority, fostering advancements in aerospace engineering and defense technologies. Knowledge of the capabilities of these weapons plays a crucial role in strategic deterrence as well. It influences decision-making processes and enhances the credibility of deterrence postures by demonstrating the ability to defend against or respond to aerial threats effectively. Addressing the challenges posed by new generation air-to-air and air-to-ground weapons requires continuous technological innovation, adaptive defense strategies, and interdisciplinary collaboration. Very soon, the ground, air, and space continuum will be a reality. Thus, developing comprehensive capability, operational concepts, and processes is essential to dominate the same. While doing so, there is a need to prioritize agility, precision, and resilience in defense systems for both offensive and defensive roles against evolving threats in the entire spectrum of contemporary warfare. Thank you.